Before giving the practical demonstration, let me show you all the necessary equipments required for this reaction. A 50 ml round bottom flask, magnetic needle, rubber septum, clamp with bow set, magnetic stirrer, reagents and reactants 4-iodoanisole, phenylacetylene, palladium catalyst, and copper iodide. Spatula, solvents, TLC and workup accessories. Before performing the experiment, we have to maintain a laboratory notebook by noting down the experiment that we are going to perform. So, initially we have to enter the experiment number, the date, then schematic representation where the substrate and the expected product were shown. Then, a calculation table where the individual reactant and substrates were calculated by using the formula millimole into molecular weight divided by 1000 equal to gram. Next, we have to note down the procedure and all the findings of the performed reaction.
So, now moving to the experimental demonstration part. Firstly, an oven-dried round bottom flask equipped with magnetic stirrer bar is backfilled with argon. Now, purge for 1 to 2 minutes. Now, fit the round bottom flask in the magnetic stirrer. Then remove the syringe and add all the solid reagents and substrates. Now we are adding 4-iodoanisole, which is a solid substrate. Followed by addition of palladium catalyst, that is bis-triphenylphosphine palladium 2 dichloride and copper iodide. Now, again purge the round bottom flask with argon. After few minutes, remove the syringe. Next, we will take dry triethylamine maintaining an argon atmosphere. At first, insert the needle to the solvent distillation head in presence of argon. Draw some argon into the syringe and pump out with the plunger. After that, dip the needle to the dry triethylamine and draw the required amount for the reaction. Make sure before pulling the needle out in the syringe so that inert atmosphere is maintained. Then pour the dry triethylamine into the round bottom flask. Then similarly, under argon atmosphere, add the solvent acetonitrile For that, after insertion of the argon balloon in the dry solvent bottle, firstly, take some argon without dipping the needle into the solvent, and then release the argon from the syringe so as to maintain a complete inert condition. Then fill the syringe with required amount of solvent and pour it into the round bottom flask. Then similarly add phenylacetylene into the reaction vessel, maintaining the argon atmosphere. Then we will allow the reaction to stir at room temperature. For that, we will maintain the stirring RPM. Here you can see we have maintained the stirring RPM, and for that we have set the magnetic stir, and then we have allowed to stir at room temperature. So the next step of a reaction is to monitor the progress of the reaction. So for that, after few hours, we have to take a small amount of the reaction mixture. We have taken it by using a capillary. And then diluted it with DCM. And additionally, we have taken the references of the substrate, that is 4-iodoanizole and phenylacetylene, in a separate vial, and we have diluted both the substrate. So, in order to monitor the progress of the reaction, we have to use thin layer chromatography. So for that, we have taken a small sheet of TLC plate where we have marked it as A, B, the reaction mixture P, and the core, that is both the substrate and the mixture, where we have marked it as M. And then we have done the spotting of the respective substrate products and the mixture, that is the core of the three. Now, depending on the polarity of the compound, prepare a solvent system. So basically, here we have prepared a 2% solvent system, that is ethyl acetate hexane, and then allow the TLC plate to run in that solvent system. solvent reaches the edge of the TLC plate, take out the TLC plate from the TLC chamber and mark the solvent font for the calculation of the retention factor. Now, in order to visualize the marked spots in the TLC plate, we will place the plate in the UV chamber and see through the glass without exposure using the short wavelength range. This is the TLC plate that we have observed under the UV light. So you can see the spots with respect to the marked ones, that is A, B, N and P. For A, you can see a distinct spot, while for B, the spot moves above the A. And for P, two spots can be seen which does not resemble with A. So, this might be the fact that the reactant A is consumed, and this can be further observed from the core mixture, where you can see the three spots. The lower one matches with the lower spot of P, and the second one matches with A, and the upper one came in the same line of B and P. So, the newly formed spot in P might be our expected product. Mark the spots with pencil so that it can be seen in visible light. Thereafter, we will calculate the RF of the spots using the formula RF equal to distance traveled by the spot divided by distance traveled by the solvent. Next, we will proceed to the workup of the reaction mixture. For this, we require a separating funnel, dry conical flux, funnel, dry round bottom flux, organic solvent, sodium sulfate and distilled water, and in some cases requires brine. First, remove the septum of the reaction vessel, then quench the reaction by adding distilled water. Then pour the mixture to the separating funnel. Now wash the top head of round bottom flux with organic solvent to avoid product loss. In this case, we have used ethyl acetate as the organic solvent. Also, wash the reaction vessel for a couple of times to ensure that no products are left behind. Then again add ethyl acetate. Now, secure the stopper and shake the funnel by holding the stopper properly so that it does not fall out. Then, open the stop end so as to release the pressure. Repeat the process 2 times and then place the funnel back on the ring stand and remove the stopper and wash it with ethyl acetate, and then allow the layer to separate. Now that the layer have clearly separated, as you can see, in this case, the aqueous layer is on the bottom, but depending on the density of the solvents, it may be on the top. Now, drain the aqueous layer into a conical flux, followed by the organic layer into a separate dry conical flux. Next, pour the aqueous layer back into the separating funnel and add fresh organic solvent and extract 2 more times. This is the organic fraction. Add sodium sulfate into it to absorb the water molecules if present. Insert some cotton in the funnel and pass the organic fraction through it into a dry round bottom flux. Again, wash the conical flux 2 to 3 times so that no products are left behind. Now, we will evaporate this organic fraction using a rotary evaporator. So this is the rotary evaporator. Firstly, set the temperature according to the boiling point of the solvent. Now, place the round bottom flux in the rotor. Next, lock the pressure valve and set the pressure of the pump. Switch on the rotating button and set the RPM and allow it to evaporate. So you can see the evaporating organic solvent is condensed and collected in the reservoir. After complete evaporation, switch off the rotation, then release the pressure by holding the round bottom flask and switch off the pump. Now remove the round bottom flask which contain our crude reaction mixture, which will be purified by using column chromatography technique.
So, this is a crude product we are going to purify. For this, we will need silica gel, dichloromethane, hexane, and ethyl acetate. Firstly, plug the bottom of the column with some cotton with a glass rod. Next, we will pack the column using silica gel, and for this, we'll have to prepare a slurry using a non-polar solvent, and here we are using hexane as the non-polar solvent. Then pour the slurry into the column, maintaining a uniform bed without air bubble. Now allow the silica to settle and then drain the solvent to just above the level of the silica. Wash the side of the column with the non-polar solvent and beat the column properly to eliminate the air bubbles that might be present in the silica pack. When the solvent layer comes closer to the silica bed, block the stopper. Now, slightly dilute the crude mixture using 1 or 2 ml of dichloromethane. Then, pour the diluted crude mixture uniformly into the column without disturbing the silica bed. Wash the RB with minimal amount of dichloromethane and pour the solution to the column, keeping some amount as a reference. After we have added the crude mixture, now we will drain the solvent, making sure that little bit of solvent is left behind so that our column doesn't dry up. Now we will insert some cotton to the silica bed so that while adding solvent it doesn't get disturbed. Now run the column using appropriate solvent system based on the polarity of the product and collect the fraction in test tubes. Here, at first we are using only hexane to run the column. After collecting few fractions, we will analyze them using thin layer chromatography. For that, we will take a TLC plate and mark the baseline for all the collected fractions. After that, we will use a fine capillary and mark the fractions in a serial manner. Before spotting each of the fractions, wash the capillary with a polar solvent and dry it up using cotton to avoid contamination. Now, we will also spot the crude mixture to compare with the spots of the fractions that we have collected. Now, we will let the TLC plate to dry, and after that, we will run the TLC plate with appropriate solvent. When the solvent front reaches the edge of the TLC plate, remove it and visualize it under the UV lamp. So, as you can see, the first spot, that is the upper spot of the reaction mixture, is completely collected in the fractions. So now, we will increase the polarity of the solvent to 2% ethylestyrene hexane to get our final desired product. After adding both the solvents in the measuring cylinder, now mix it properly and then pour it into the column. Now, again after collecting some fractions, we will check the TLC of those collected fractions and visualize it under UV lamp. Under UV light, we have observed the product in the collected fractions. So, we are now ready to concentrate the fraction to get the product. For that, we will take a 100 ml round bottom flask and note down its empty weight. fractions one by one into the round bottom flask using a funnel. Then, we will wash the test tubes thoroughly with ethyl acetate to avoid product loss. While pouring the fraction, make sure that it doesn't exceed the halfway mark of the round bottom flask. Now, we will evaporate the solvent in a rotary evaporator. After concentrating the fraction in the round bottom flask, we will feed the RB to a vacuum pump so that the trace amount of the solvent present is evacuated. After removing the RB from the pump, we will note down the weight of the round bottom flask. After isolation of the product, it is mandatory to confirm the product using various spectroscopic techniques like NMR, HRMS and IR. Since our expected product is already known, so we will characterize it only through proton and 13 carbon NMR spectroscopy. In case of unknown compounds, all these spectroscopic techniques need to be done in order to confirm the product. After taking the proton and 13 carbon NMR spectra, we found that it is characteristic with our expected product. After characterization, we will also have to calculate the percentage yield of the reaction, and for that, we will use the formula moles of the product divided by moles of the reactant into 100. The percentage yield of this reaction is found to be 72.6%. All the findings of this reaction is properly documented in the laboratory notebook. So, this is all about how to carry out the reaction under inert atmosphere. Thank you.